Hey folks, this lesson is testing differences between the means, independent samples, and the standard deviations are known. So we're going to do a z-test on this because we know the standard deviation. So two samples are independent when the sample selected from one sample population is not related to the second population. So nobody in here is related to anybody here. There's no kind of pairing we can do. So two samples are dependent when each member of one sample corresponds to a member of the other sample. So this guy corresponds to this guy corresponds, and so on, okay? So dependent samples are also called paired samples or matched samples, okay? So classify as independent or dependent and justify. So here we go. The weights of 65 college students before their freshman year and the weights of the same 65 college students after their freshman year. Well, that one's totally dependent because the weights are the same student and they're related and you can pair them up, okay? How about this one here? Scores for 38 adult males on a psychological screening test for ADHD. And then the second sample is scores for 50 adult females on a psychological screening test for ADHD. Well, those are independent. I can't pair them up. They're different sample sizes. So those are totally independent of each other. So dependent samples often involve before and after results of the same person or objects, such as a weight starting a diet for before and after, or identical twins can be paired up. So anything that can be paired up or matched up, those are dependent, okay? In this section, we're going to learn how to test claims comparing the means of two different populations using independent samples, okay? So for a two-sample hypotheses test, sorry, with independent samples, I did a brain freeze right there. The null hypothesis is a statistical hypothesis that usually states that there is no difference between the parameters of the two populations. So the null hypothesis is always going to have the symbols with the equals involved. The alternative is going to be true when your null is false, and it'll always have the greater than or not equal to or less than. Okay, ring a bell? So our testing statistic is the difference of our sample means minus the difference of our population means divided by the standard error right there, okay? And the standard error is just a little twist. So the conditions for a two-sample z-test, okay? You got to state that both the standard deviations are known and the samples are random and they're independent. And the populations are either normal or the sample sizes are greater than or equal to 0 or 30, sorry. So the test statistic is x1 minus x2, x bar, the sample means, the difference of the sample means. And our standardized test statistic is going to be the difference of the sample means minus the difference of the population means divided by our standard deviation, except our standard deviation is the standard deviation squared divided by the sample size plus the other standard deviation squared divided by its sample size and square root all that. So that's going to go right down underneath there, okay? So all the guidelines are the same for the two sample z-test as were for the one sample, so we'll see those examples coming up. So a credit card watchdog group claims that there is a difference in the mean credit card debts of households in New York and Texas. So the result shows a random survey of 250 households from each state. The two samples are independent, so that's important right there. This is important, a random sample. The sample sizes are important, so because it doesn't say it's normal in here. I don't see anything about normal, but the sample sizes are greater. And here's the standard, the population standard deviation for New York and the population standard deviation for Texas. So do the results support the group's claim? So we're going to use a 5% level. Okay, let's state the conditions, you guys. They gave us the population standard deviation, so they're known. It said that they're random and independent, and both the sample sizes are greater than or equal to 30, so we can go ahead and go and proceed with the z-test. The claim is that there is a difference in the mean credit card scores, so that means not equal to. That's going to be our claim, so our null is going to be equal to. Okay, so there's our null, there's our claim, not equal to, so can we reject the null? Okay, so because it's a two-tailed test with theta equal to 0.5, our error being 0.5, the critical z-scores are negative 1.96 and positive 1.96. Okay, so anything below negative 1.96 or above 1.96 when we calculate our z would give us enough evidence to reject our null. So there's our standardized test statistics, plugging in the information. Now this is 0 because our null is mu1 equals mu2. So if they're equal to each other when we subtract them, then that's going to be 0 right there. Okay, so crank that out and we get negative 0.82. Now is that less than that? It's not. So the figure shows, always draw the figure, you guys. And in this case, we're drawing the rejection regions from negative 1.96 over here to 1.96 over here. And here's the z-score right here. And because this z is not in the rejection region, we're going to fail to reject our null hypotheses. So our interpretation is there's not enough evidence at the 5% level of significance to support the group's claims that there is a difference in the mean credit card debts of households in New York. Okay? Hope that makes sense. And if you're in my class, that's going to be your assignment. Take care.